Hello, good evening, everyone. Before we start, we are encouraging everyone to post a picture of themselves during this webinar on their Facebook and Instagram accounts and use the hashtags #DX, #Technology Beyond the Horizon, #PropagateXRadiate, and #REC Free Webinars.
Also, for those who weren't able to join us in Zoom, you may watch this webinar in facebook.com/reg.org.ph/live. And if you have questions, you can type it in the Q&A box below, so we will be able to see it and therefore ask our honorable speaker at the end of the topic.
Tumayo po tayong lahat, ilagay ang kanang kamay sa ating dibdib at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Bayang magiliw, perlas ng silanganan, alab ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyang ka ng magiting, sa manlulupi, di ka pasisiil, sa dagat at bundok, sa simoy at sa langit mong bughaw, may dilagang tula at awit sa paglayang minamahal, ang kisap ng watawat mo'y tagumpay na nagniningning, ang bituin at araw niya kailan pa may di magdidilim. Lupa ng araw ng walhati pagsinta, buhay ay langit sa piling mo. Aming ligaya na pag may mga api, ang mamatay ng dahil sa'yo.
Welcome, everyone. What a pleasant evening to spend with you all. My name is Phoebe Joango, 4G1 Alpha Charlie Sierra.
And my name is John Verhel Bautining, Delta Victor 1, Zulu Charlie Nancy.
And we would like to welcome you all to DX Technology Beyond the Horizon, the Space, Episode 1, A Journey with NASA and Boeing, brought to you by Radio Engineering Circle Incorporated.
But before we start, reminding again everyone to post a picture of themselves during this webinar on their Facebook and Instagram accounts and use the hashtags #DX, #Technology Beyond Horizon, #PropagateXRadiate, and #RecFreeWebinars.
We would also like to encourage everyone to join the Radio Engineering Circle. You may log on to rec.org.ph/join, and for young engineers ages 35 and below, you may also join the YES PTC by reaching us at yes.ptc.ph.
Also, by the end of this session, you will be provided the link for the feedback form. This will be the prerequisite for your e-certificates, so please do not leave the session without completing the form.
If you have questions on the infos being presented by the speaker, please feel free to ask on the Q&A box below. It will be asked by the moderators at the end of the presentation.
And now, to officially begin our webinar, may we call on the chairman of the Radio Engineering Circle and Philippine Technological Council Young Engineer Section, Engineer Gerhard P. Tan.
Hi, good evening, everyone, and welcome to DX, Technology Beyond Horizon. This is first of its kind and one and only. And I wish to welcome everyone in this webinar series on featuring the space with our speaker tonight, a prestigious engineer in the United States. So I welcome also the participants in tonight's webinar, especially our comrades in the Institute of Electronics Engineers of the Philippines, and likewise also with the Society of Aeronautical Engineers of the Philippines who will be participating tonight. Likewise also to all the other engineers and students across the country and even in the Gulf region. And I saw also some known engineers who are participating tonight coming from the US, Canada, Australia, and I think there is one from the New Zealand. So well, tonight please maximize this opportunity, ask question, and also participate actively as we have a distinguished speaker who's going to share his wondrous experience during his engineering stint, both in Boeing and in NASA. So at this point in time, I wish to welcome everyone and enjoy your night. Good evening.
Thank you very much for those wonderful remarks, Sir Tan.
Again, just to remind everyone, when you post your photos on Facebook or Instagram, use the hashtags #DX, #Technology Beyond Horizon, #Propagate X-Radiate, and #REC Free Webinars. So, Verge, what exciting topic are we about to discuss tonight?
Well, Phoebe, our topic for tonight will take us to space as our resource speaker will join us in our journey with NASA and Boeing. So without anything else, it is an honor for us to introduce our resource speaker for tonight. He is an experienced engineering professional with BSE and MSEE and over 25 years of experience in defense, aerospace, and aircraft industries. He graduated with honors in University of Maryland. He led the system integration and checkout of wide-body jet airliner Boeing 787 for its first flight and delivery in Everett, Washington. He has an extensive RF and microwave experience, having designed, tested, and developed many RF-related systems such as radar, DF, avionics, EW, and antennas. He also joined the International Space Station way back 1997 in Houston, Texas, and he has designed, implemented, load control, monitor and troubleshoot ISS flight software, simulation, and network operation. May we call on Mr. John W. Basie. Let's give him a virtual round of applause. Good evening, sir.
There you go.
Yes, sir.
Hi, good evening.
It's the new virtual round of applause.
It's the new normal.
Yes, sir.
Okay, so you can share your
You
presentation.
can share your screen now, sir. Yes.
Okay. Good evening. Can you hear me?
Yes, sir. Loud and
Loud and
clear.
clear.
Yes.
Loud and clear.
Okay. First, we'd like to congratulate you on your Independence Day. I'll have to admit, when I visited the Philippines, I've always found that the country was so free and welcoming, and I hope you never lose your freedoms, because I was sort of astounded how free the Philippines are. And I met my wife there, and we always enjoy the culture and the family traditions of the Philippines. My name is John Basie. I'm speaking to you from Houston, Texas. We've lived here 24 years, my wife and I. My wife is from Baguio. We also have a home in the Philippines. So I'm very familiar with the Philippine country and culture. Today I want to talk about the major programs primarily related to NASA that I've participated in, and give you the engineer's point of view. So much of what you see from NASA is like a PR, because NASA has to go to the government to get funding. So they're just like they have to sell themselves. So everything you see with NASA is scrubbed and polished, and you think it's the most wonderful thing in the world. But when you're an engineer, you work for big companies, you know there are all kinds of problems. I've been reminded to thank Ornan for giving us the opportunity to speak with you today. Thank you, Ornan. And Ornan's a good friend of my wife, so she wants to say hello too. Okay. Let me see if I can make this thing work for us here. I was working for Boeing, and I got a contract to go to Cape Canaveral and work on this rocket. This is the Titan. This is a Titan 34D. This is a workhorse that NASA and the Air Force use to put satellites into space. This upper portion here is covered. In there is a payload, which is usually either a military or a commercial satellite. And then there's an upper booster stage here. So I had never been on a NASA mission like this. So I went to Cape Canaveral, which is a very beautiful part of Florida. And when you drive up there, you go to each contractor has has a little office area and labs and so forth. When you drive out to the gantry, you see this monster of a piece of hardware sitting there. This thing's about 10 stories high. And you don't appreciate it till you get up close to it. It's just a monster. And the first thought in your head is this thing is never going to leave Earth. It's just so massive. Our job there was to integrate the payload with the upper stage and then support the launch. And what happens at a launch like this is very complicated. Each of the contractors has their own checkout of their hardware. Then they have to check out the interface from their hardware to the next hardware, and then the
Excuse me
Sir
po,
subsystem
Sir
checkout.
BC. Sir,
Second,
excuse me.
Yes.
Sir, do you share your screen now? Do you have something to present? So we could see your presentation, sir. You can start sharing your screen.
can you see the screen?
Not yet, sir.
Oh, I'm sorry. Let me see where the share is. I thought I shared it.
Down there.
Hey, John, I see your video fine. Oh, now you went away.
Okay, we can see your screen now.
Can you see the
Yes, sir.
screen now with the missile?
Yes, sir.
Yes. Yes, sir.
Okay. Yeah, if there's something wrong, please tell me. Okay, this is a Titan
Okay.
34D. The upper portion here is a payload, and underneath the shroud is a payload and a booster. When it goes to space, this shroud comes off and they launch the satellite into a geosynchronous orbit. This is what I've been talking about. This was my first job down at Cape Canaveral. And after we integrate our hardware, we have to check the interfaces, and eventually it comes down to a checklist for the whole vehicle. So maybe 4 or 5 days before the launch date, they'll start a countdown. And each of the major systems has to report in the status of their particular system. So like propulsion will report in that their rockets are fueled and pumps are working, everything's a go. And then the next system will come in. Avionics will report that their telemetry and their guidance is go. And then payload will come in and say payload and booster are go. So when everything is a go, then you start to count down to actually igniting the rockets. And it's pretty intense. You're working 24 hours a day, and by the time you get ready to launch this, you're just exhausted. So when they light these solids off, there's a tremendous roar. It just literally, we're about a mile away from the launch pad, and it literally shakes our building. And it slowly lifts off the pad, and you just see it rise up and go over the horizon. So it's really quite a sight for the first launch. And as you're probably aware, we always launch to the east. And the reason for that is the Earth is rotating toward the east. When you see the sun coming up in the east, it's really not the sun coming up, it's the Earth rotating toward the sun. So the surface velocity near the equator is about 1,000 miles an hour. So from a space point of view, that rocket has already got an initial velocity on it. It means you can boost a bigger payload. So that was my first introduction to how NASA does things. Let me show you the upper stage here. Okay, I assume you can see this one. This is the upper stage booster. Most of the activities, the first launches go into a low space orbit. And that's only about 200 miles up. In fact, the space station is about 200 miles above the surface of the Earth. In order to get to a geosynchronous orbit, you got to go 22,000 miles. So the space station is what we call a low Earth orbit. This booster takes a payload from that low orbit up to 22,000 miles out. So when you're up 22,000 miles, you're going very fast, but you're staying over the same spot on Earth. So they'll launch a satellite and it'll be hanging out over top of Hawaii, say. And that's where it'll be. It'll spend its whole life there. The actual payload has little boosters on it that keep it orientated and keep it in position. This is the upper stage booster needed to get it into orbit. Boeing built this and we launched lots of them. This is a picture of the upper stage holding a satellite. Satellite has all kinds of antennas because this is a communication type satellite. So it's coming out of the bay. This one's coming out of the bay of the space shuttle. There's a spring in there that lets it go, pushes it out into low orbit. This shuttle moves away from it. And then at a certain countdown, they'll ignite this particular rocket. And that'll start its journey into a geosynchronous orbit. And that's takes a lot of energy to get it up to 22,000 miles.
And when the astronaut comes back.
Okay. Okay, my next job was really working with the shuttle. Do that again here. Yeah, here, this is a little better picture. This is the upper stage booster, and this is not showing it. It's a classified, probably, satellite. And it's coming out of the equipment bay on the space, on the shuttle. The doors of the shuttle open up and it pushes this out into orbit. So the shuttle is used primarily to build the International Space Station. This is what the space station looks like today. It's a pretty massive piece of hardware floating around the Earth. All these panels you see here provide electrical power for the space station. And they have to, as the space station goes around the Earth, it goes around 16 times a day. Those panels have to be orientated toward the sun as it goes. So we have navigation software on board that calculates the angle of each array to the sun to maximize the energy. If for any reason they lost control of the space station and they couldn't orientate these, the station would lose power very fast, everything would freeze up, and everybody on board would die. It's that simple. That's how critical it is. So the energy from these panels provides the power to run all the computers, navigation, keep the air conditioning running and the heaters running. So it's a critical part of the space station. But you can see it just doesn't float up there. It has to be active. These are always, you can see they all rotate, and you have to maintain the stability of the space station as well. The second launch I was involved in at Cape Canaveral actually occurred at Kennedy Space Center. Kennedy Space Center and Cape Canaveral are adjacent to each other. One's a NASA control, one's an Air Force control. So in this case, we put our payload and our IUS inside this equipment bay on the shuttle. And it's quite interesting. The shuttle stands on the gantry there, and there's a device that swings over and locks onto the equipment bay and allows us to load it up with the equipment. So this is quite an operation too. There's all kinds of safety features involved. They've got fortified bunkers over here, where if there's a problem, the ground crew can run and get into bunkers, and you know, if there's an explosion or anything like that. These type of operations are very dangerous. People don't realize it. These are loaded with fuel. There are all kinds of explosive devices inside the equipment bay because the separation devices are all explosive devices. It's a pretty hazardous environment. This launch occurred in Kennedy in about the mid 1980s. And I went to, eventually I went to Houston and joined NASA and Boeing in the Sonny Carter test facility. And before we could build up this space station, we had to build each of these individual modules. There's roughly 54 computers running on the space station. Each of these modules have one or more computers in them. So each module has to be able to connect into the power system, connect into the air conditioning and environmental systems, all the warning systems, the habitat, and so forth. So each one of these, we'd have a simulation, and we'd simulate that particular module talking to the next, talking to the next. So as we built this up, it got more and more complicated. So we spent, before anything goes into space, it's thoroughly tested. The simulations are all worked out. All the anomalies are supposed to be resolved. And then you put the thing together and take it to Kennedy Space Center and launch it up into space. So that was my job, was running all these simulations, making sure they all work. There's a lot of good information here. You know, the space station had many international partners. I think we had 19. So we had the Japanese, the Europeans, UK. All of them have parts of this system, the Canadians. So not only do we have to do their integration, but they have to develop the simulations for their particular functions. A lot of detailed work. It's amazing how much detail goes into some of these things. Yeah, let me get. We just play this little video for you that we talked about. As you see, NASA has lots of good PR videos and diagrams and stuff. But what we find out from the space station and man in space is that man is not really equipped to be in space. Skeletal system degrades. The fluids in his body migrate up into his brain. There's a lot of cosmic radiation. So even though it looks glamorous, it's very hazardous in space. These are all the contributors to the space station. The space station is now complete, operational. And we have lots of activity on the space station. They're replacing hardware all the time. And we're running experiments all the time. And they're swapping out crews. So it's here's the interior. You can see the computers. We have computers everywhere. It's not luxurious. You can see it's sort of crowded and chaotic. It looks chaotic, but we try to cram as much as we can into the space station and still make it safe. So, and it's been up there for 15 years or so, I believe. See if I can get out of this. Okay. And right now, NASA has an effort to build a space station that's going to orbit the moon. This is called Gateway. It's a much smaller version. They want to be able to ferry astronauts from the Earth up to this orbiting space station around the moon, and then have missions from that space station to the surface of the moon. This is sort of ambitious, but it's already in the works. And eventually we'll have a permanent base on the moon. And from that moon base, we're going to launch missions from the moon to Mars. And it'll be quite a task to do all that. Let's see if I have another. But right now, they're getting ready to start this effort on the moon. This is a moon effort. I think Donald Trump has authorized him to start planning for a moon mission. So it'll be quite exciting to see this eventually develop. Okay, this is this goes through the same process. The shuttle has been retired, so we don't really have a good launch system. We've been using the Russian system. So now Boeing and Grumman and the contractors have developed a launch capability for the US. This is a new rocket system. As you know, the shuttle was aging and was very unreliable. We had 2 fatal crashes of the shuttles. What happens in the space agency is they plan a mission or a piece of hardware. By the time they develop the hardware, prototype it, build it, and get it in space, everything is obsolete. The computers are obsolete, components are obsolete, so it's very hard to keep everything up to date. So that's one of the problems when you have a program that stretches over years and years. So with the shuttle, there were so many things obsolete on the shuttle, they could virtually not keep it flying. So we got new missiles, new systems. I think they'll be a lot safer. One of the big drivers in all this is the SpaceX Corporation. SpaceX is been showing that they can deliver humans and hardware to space at about 1/10 the cost of NASA. So they're becoming the real active players in space now. They've already delivered hardware and crews up to the space station. This is a little docking simulation. They have to dock their hardware with the space station. There are little sensors in there that align the capsule as it comes up. The Falcon 9 is their launch. They've developed a big launch capability. They've had multiple launches, and they have been able to recover the boosters and refly them. Okay. How's my time doing? Do I have more time? Okay.
Yes, sir. We still have time.
Well, this is their Dragon. This is a capsule they use to put the astronauts in and go up to the space station. These guys are really doing a good job. They know how to cut the corners and make things work using commercial equipment and so forth. Ultimately, they're going to have a spaceship called Starship, which is going to go take us to the Mars, Moon, anywhere we want to go if you can survive the trip. The problem is we're finding out that the human body is very frail. And if they go to Mars, it's very hazardous. When you get on the surface of Mars, there's lots of radiation, cosmic radiation, and so forth. So the human space flight is glamorous. NASA likes to promote it because they get money for it. But really, humans are not anywhere designed to be in space. They're finding now prolonged weightlessness, the body fluids and the human migrate up into the brain and so forth. They're finding the bones deteriorate. They're finding your eyes deteriorate because there's no gravity. So prolonged weightlessness is very hard on the human body. So, that's SpaceX is really going to be the big driver in a lot of the new programs. The recovery of these modules are still the old-fashioned way. They land them in the ocean Pacific. This is one of them landing, and they recover it. They have to be able to physically spot it. People don't realize NASA and the Air Force have tremendous telescopes. They can actually look up in the sky and see what's going on with great detail on any satellite, space station, and so forth. So it's literally not only do we have telemetry, but we also have visual, if the sky is clear, you have visual contact for them. Okay. And my assistant is saying I got to wrap it up here. Let me see if there's something good here. There are lots of pure science that NASA does, but they don't do enough of it because so much of the budget goes to manned flight. But they're doing research on comets. The big thing now is the sun. They're finding out the sun activity is affecting our climate. There's so much that we need to learn in basic pure science, from meteors to other planets, the effects of the radiation in space. So most engineers like myself would like to see more money dedicated to the pure science and less to the manned flight. Manned flight's very expensive and dangerous, so they could spend that money, I think, and get a lot more in pure science. Okay. There'll be another session later, a couple weeks, a week, sometime from now, on avionics. I have a great deal of experience in avionics, both military and NASA. And then there'll be a third one on artificial intelligence. No. And then artificial intelligence will be one of the greatest impacts on our culture, probably since electricity. And it'll change everything we're doing and the way we do things. But that more or less concludes my presentation, unless there's more questions. No, that's next session. Okay, gentlemen, are there any questions?
Well, thank you, Sir John, for those wonderful information. These were really helpful information for us to better understand your stint in NASA and Boeing. But before we proceed in our question and answer, I would like to remind everyone to not leave the session without completing the feedback survey. This will be the prerequisite for your e-certificates. Also, Phoebe.
Also, when you post your photos on Facebook and Instagram, use the hashtags #DX, #Technology Beyond Horizon, #Propagate, #XRadiate, and #REC3Webinars.
Also, we would like to acknowledge the presence of the Professional Regulation Board of Electronics Engineering, headed by the chairman, Dr. Alnar Detalia, and member engineer Enrico Claro del Moro.
No, that's a different,
We would like to
it's a different
acknowledge the
session a week
presence
from now, Margaret.
of the Country Registrar of Philippine Technological Council, Engineer Romulo Agatep. And we would also like to acknowledge the presence of Mr. Kerry Swallow, engineer at NASA, who will be joining us tonight as one of the panelists.
Good evening, sir.
Good evening, sir. So
Thank
now,
you.
let us proceed for the question and answer. We have lots of questions here, sir, because a lot of people are really interested what it's like to work in NASA, what it's like to work in space. Okay. I believe, sir, you have a more topic to discuss. Am I right?
That's going to be another session, Patrick, Verhel. That's going to be episode 2 and episode 3. So that's going to be a couple of weeks from now.
Okay, sir. So we will be proceeding for the question and answer portion. Phoebe, for the first question.
For the first question, sir, how do you maintain the solar panel or power source of the ISS? And what is the lifespan prior modernizing those solar panels?
The solar panels are rotated on a big gimbal, and we have one of the modules there is built by the Russians, which is a navigation module, and it calculates where the sun is as the space station goes around the Earth. And by that calculations, it rotates those panels to maximize the exposure to the sunlight. And I forgot that those panels develop, I don't know, Harry may know, I think 50,000, you have 50 kilowatts of power at least. And that runs all the air conditioning, the scrubbing of the air, the recycling of the air, the cooling, the heating, and all the computers. So it's a redundant system and it's very critical. If for example, you're traveling to Mars and your solar panels fail, by the time you get to Mars, you'll be a block of ice. You'll just be frozen solid. The temperature outside the space station is probably around minus 100 degrees or so. So the panels are essential to keeping the system running.
Okay, sir.
And we've had several emergencies on the space station. Of course, NASA doesn't publish those, but there's when the system fails, it's very critical and it's hard. You can't just like with an airplane, you land and fix it. In the space station, you're on your own. You got to have a spare. You have to work around it until they bring up another cargo bay, cargo shipment to you. So, space station is a very it's a very hazardous place. But we've been mastering all those risks so far. Next.
Okay, sir. Before we proceed for the next question, I would like to acknowledge also Engineer Herminio Orbe, also member of the board of ECE. Okay, for the next question, sir, what are the professions of the people inside the ISS? Is it possible for electronics engineer to join the ISS?
Their professions?
Yes, sir.
Well, the NASA is the oversight agency. Almost all the work, all the hard work is done by contractors. Boeing builds most of the stuff, somebody built the shuttle and so forth. NASA builds very little. They more or less come up with a concept and they provide the funding and they provide the coordination. So when you get a contractor, you'll have software engineers, you'll have aerospace engineers, you'll have structural engineers, you'll have thermodynamic, you'll have people writing simulations. You're talking about on a big program like the International Space Station, I have maybe 20,000 people working directly or indirectly supporting the space station. So there's a wide variety. And if they're running experiments, one of our good friends runs all the payloads. He's a biology engineer, and they run experiments on animals, on plants, on diseases, anything to do with microgravity. They put together these experiments, and then the results are shared worldwide, which is a good thing. So there's anybody with a technical background at all can be involved in NASA. But to qualify to go to space, if you're going to be a commander of the space station, you have to be a test pilot. And those guys go out to Edwards and train on the latest fighters, experimental airplanes. And these guys are very sharp. They can, when there's an emergency, their guys are just as cool. You could not believe how cool they are. But those are the commanders. The people that sit behind them are mission people and so forth. And their job is not to fly the shuttle or do all those things. Their job is to maintain systems and run experiments, keep the station running. So the qualifications are quite different depending on your job, your task. Next.
Okay po. Thank you, sir. For the next question, this is from Engineer Javita Chonko. What is your recommendation to students or young engineers who wants to specialize in space technology?
Well, I think anybody that's going to do something on the forefront, whether it's defense or aerospace or almost any field now, even medicine, is to have a good background in computers. Almost everything now, before we build Boeing, before they cut the first piece of metal to build an airplane, they build it on the computer. They've simulated on the computer. They've designed the parts, and by CAD, they've mated the parts together on the computer. They've done the structural analysis, the fault analysis, everything's done on the computer before they even start anything. And then afterwards, they build simulations of what happens if this gets overstressed or whatever. And it's really quite remarkable. If you go up to Boeing, they have a tremendous capability for simulations. You can sit down in a simulated cockpit and fly a 747, or I fly the 787. And you can kill an engine, you can do all kinds of things in simulation and see how the system works. Where in real world, you're not going to do something like that. But it's all done on a computer, and that's the key to it. Unless you hate computers, which some people do, then I don't know what other skills. Maybe you learn to fly airplanes or something. But the computer is becoming quite essential to almost all these endeavors. And of course, math and computers go together. You have to have math and computers. Okay.
Okay, sir. Math. Thank you, sir. For the next question from Engineer Armand Orsal. Good morning, Sir John.
Morning.
Great presentation. My question is, in your stay with NASA, how many times did the astronaut say, Houston, we have a problem?
They say it probably 100 times before they even get off the ground. You know, the way that works is each system, whatever it is in space or whatever, each system has a guy on the ground who is monitoring what's going on with his system. And I think Kerry Swallow was part of that. You know, you have a system, you got a guy who knows everything about the environmental control system, the air conditioners and air conditioners on board. You have another guy that knows everything about the navigation. Another one knows everything about the fire and warning system. Another one knows about the propulsion. So movie was Houston, we have a problem. Now you got 6 or 8 guys up there, each with their own system to worry about, each with their own problems. So the first thing they do is, if you got a problem, you say, what kind of problem do you have? You know, if it's propulsion, you go to the propulsion guy. And hopefully he's already got the telemetry. Instead of them telling Houston they got a problem, Houston's telling them, hey, we see something, we have an anomaly here. You need to look at this. So in reality, you got Houston telling the space station, basically, we're seeing a problem, you know, you need to go check this or whatever, long before the human up in space recognizes it, hopefully. So Houston, we have a problem, has been around a long time, and it'll probably be, when we go tomorrow, we'll still hear Houston got a problem, and it'll take 24 hours for that message to get to Houston. So, you know, after a while, it's like, hey, you got a problem 24 hours ago, and we just heard about it. Next.
I would like us to ask Sir Kerry.
Yes.
Is there anything you would like to share about Houston? We have a problem.
I was just reflecting. Basically, what John is saying is, it's more like, this is Houston. You have a problem.
Yeah. Good luck.
Yeah.
So with a good system, you know, you got big computers down on the ground. You got experts. You know, may have 5 experts just on one little system. And if they see an anomaly, they start digging into it. They may even run a little simulation. And they may not even tell the guys up on the space station until they're sure they know what the problem is and what kind of action to take. So that's,
Of course,
Okay.
everybody, I would just point out that original quote is from Apollo 13, And that's the only time that I know that was actually officially said during a mission over the main communications loop. But as John says, it's probably said a lot informally inside the control room.
Yeah. And if
Okay,
you come to,
thank you.
you guys, if you come to Houston, you can go to their museum, and then you can take a ride over to the control center and see the actual control center, which is staffed 24 hours a day. They're there watching the space station. I think Orman went with Merovic there, and it's very informative. Okay.
Okay, sir, thank you. To our participants, you can use the raised hand here in your Zoom, so you can ask directly your questions to our guests. We will just call you of whom to ask. Okay. Okay. So let's just go first to our next question from the Q&A box. Sir, what are your thoughts regarding the privatization of space travel, and do you have in any capacity any responsibilities in the recent launch of astronauts by SpaceX?
I think commercialization is probably the greatest thing that's happened to the space program, because NASA, like any organization, if they're around a long time, pretty soon they become a bureaucracy, and they're not pushing hard enough for the science, and they're not pushing hard enough. They don't want to take any risks because their careers involved and so forth. So it was me working for NASA was very frustrating. It was very slow. You're talking about years to get the first piece of hardware. When I worked for the military, we were flying 2 missions a day at Edwards. We were loading new software every morning. We were solving problems. We were crashing airplanes. It was very high pace. NASA is just the opposite. It's very, very slow. They're very methodical. The commercialization has allowed the contractor to take the responsibilities, and they've already shown that they can do it for about 1/10 the cost of NASA. And they're very good. They have the best people, and they're very results orientated. So I think commercialization is the only way we're going to go and survive and compete with the Chinese and the other people, is to commercialize it. Now there's a lot of players in space now. You don't realize you got the Indians, the Chinese, of course, and the Europeans, and everybody wants to get in space. Space now is becoming profitable. Everybody wants their satellites up there for communication, for navigation, for surveillance, for weather. So this is a sort of a turning point here where space is becoming commercialized. Okay.
Okay, sir. For the next question, sir, with your involvement in the following projects in Houston, Texas, such as the International Space Station, Titan T4D, Space Shuttle launches, Lunar Orbiter, Moon Base, Moon to Mars, and SpaceX, which among those is the most challenging one?
They're all different. Space station is probably the most challenging because it's so complex. We have over 50 computers running all the time, talking to each other, monitoring, crashing, doing everything computers normally do. So it's a real challenge. Space station's a real challenge, and you're dealing with a lot of people. So that was very challenging. The lunar orbiter will be also challenging, I think, because the thing with the space station, it's in a low Earth orbit. It's very low. It's not deep space. It's not even medium space. So we had a lot of problems just in a low orbit environment. When we go up to the moon, I think I don't know how far away it is, but it's quite a distance. It's not an easy an easy task to recover crew if there's a problem. In low orbit in the shuttle, we have an escape capsule they can get in and come home. Around the moon, I don't know what they're going to do if they have a real problem. But you know, if they're going to have space travel, you have to learn with humans. You've got to learn all those problems. I think the real future is not human space travel. I think it's robotic machine space travel. We can send machines to go do almost anything a human can do, and there's no environmental support. You don't have to feed it. You don't have to give it oxygen. You know, just turn it on, and it can go. It can go. We've had them running through the universe now for 40 years, 50 years. So I think is artificial intelligence and robotics. But that's not glamorous. You know, NASA has the glamour of space travel to get their budget. The NASA budget now is $22 billion. And before the space station was finished, it was taking up most of that budget just for the space station. So we had 10 years or 15 years when there was very little pure science. You know, we could have had rovers on lots of other planets around Titan, the Titan being Titan base, and lots of other things. But space station sucked up a lot of the funds. So unfortunately, NASA has to sell itself to the Congress and to the American people to get funding, and that's the glamorous thing, is that everybody wants to have a human in space. So hopefully that'll change. We'll see.
How about you, Sir Kerry? What among those mentioned projects, what do you think is the most challenging one?
Well, I think John, as John touched upon earlier, I think from a different standpoint, the Mars mission is more difficult for several reasons. First of all, because of the human frailty, you have to protect the human body. It's a long mission, and if somebody becomes gravely ill on the way out, it's pretty bad for morale to ride in to Mars and not be able to return to get treatment for your crew member. It's just the sheer distance and the unavailability of a quick return to Earth. I think that makes it very risky and very challenging from that standpoint.
Oh, okay, sir. We have a question from our participant, Mr. Paulo La Laguna. Hello, Mr. Paulo.
Philippines, and good morning to Mr. John and Mr. Kerry.
Morning.
Morning.
I think to have a follow-up on what Mr. John is talking about regarding China's, regarding the earlier ago when you talk about NASA maybe coming back to moon, probably as a next project. And it just so happened that recently Netflix released a comedy regarding this space race thing, right? The Space Force, wherein there's a competition between US and China with respect to getting back or getting to the moon. So what are your points? What are your point of views on this thing? How realistic is this?
Okay, yeah, you were broken up a little bit, but China wants to become a major space explorer for the prestige. I don't know if there's, I think there's an effort on their part to challenge the US on space dominance. The problem with the moon is I don't think it has any real commercial value or value I'm aware of. If you have a moon base, people talk about a moon base, you have the same problems. The moon has no atmosphere, so there's a very strong radiation. You know, if you set a plant outside on the moon's surface, the cosmic radiation would probably kill it in about 20 minutes. So the human body has to be shielded. We don't know of any water, any other thing. So a moon base is very challenging. I suspect they can edge of the shadow of the night shadow, so it's cooler. But China, I think, wants to do it for the prestige. Of course, you know, there are byproducts. If you have a good missile system to launch, you have a missile system for military. And so there are some spinoffs why China wants to do it. China has a pretty good program. I think they're pushing it hard. In fact, if I know the Chinese, they may land a man on Mars, a one-way mission, even just as a one-up. But say, okay, we'll put a man on the Mars, but we're not going to bring him home.
They'll find a volunteer.
So it's we'll see how it goes. I think the Chinese have real capability. Next. You want to add to that, Carrie? You're going to volunteer to
Anything, Mr. Carey?
space?
No, I'm retired. I'm retired from space.
Okay. The next question is, what are your involvements in the military fighter aircraft?
Oh, yes, my career has really been in the military. I've worked on almost all the fighters and bombers. I did the integration and testing of the B bomber, and that airplane is deployed around the world. It carries nuclear weapons and conventional weapons. Very complex airplane. You have 4-man crew, 2 men in the back. One is a defensive officer, one is an offensive. So you have all the defensive systems, jammers, and so forth. The offensive one, you've got the radar and the beacons and everything for the offensive. And then the F-22 is a fighter we developed by Boeing has the avionics package on that one. We worked on that. So I've worked on, in some way, most of the fighters, you know. Additionally, we didn't work on programs involving ECM. One of the first programs I had was developing airborne ECM systems that were used in Vietnam during the Vietnam War. So there's a lot more challenging, faster pace if you're in the military. Because there's always a threat. They always want something new, something better. It's very enjoyable, fast pace. Anything else?
Sorry.
Sir, we have a question from our participant, Mr. Joshua Vida. Hello, Mr. Joshua.
Evening, Sir Joshua. Hello, Sir Joshua.
I think Houston, we
Houston, you have a problem.
have a problem. I think that's a proper first.
Okay. I believe Sir Josh was experiencing a little bit of
Yes.
difficulty.
Maybe we just need to proceed to our next question to Mr. John. So, Mr. John, in your resume, can you elaborate why 787 Dreamliner did not go airborne without your certification?
You're talking 737 MAX.
Dreamliner.
The Boeing has a big problem with the 737 MAX right now, and they pulled a certification because the airplane can be unstable in certain flight regimes. So I assume he's talking about the 737. The the Dreamliner is very successful. Boeing is flying them and building them, but it's the 737 MAX is the problem. And what happened there was the engineers were pushed aside, and the management decided to build an airplane without relying too much on engineering, put bearings and other things on the airplane. And the software didn't keep up with it. So the heavier engines shifted the center of gravity. So on takeoff, if the pilot gets close to the stall regime, the software would jam the aileron down so that the nose would go down, and then it wouldn't let him pull it back up. And so it just drive the airplane into the ground. So the 737 has been a disaster. It's cost Boeing billions and billions. We fired the manager of the program. Anytime you have a big company like Boeing, which has over 100,000 employees, you always have problems with managing those enterprises. And if what happens when profit gets ahead of good engineering, you get a 737 MAX. But I think they can fix the problem. I don't know why they're having so much problems doing it, but they can fix that problem and get the plane flying. That's a good job for engineers. You know, you got a good, sharp engineering come in there and go to the simulation and come up with a better software module to recover from a stall. Lots of opportunities there, guys.
Okay.
Anything else?
Sir, a lot of people really wants to go to space. So there's a question, sir. Is there a possibility for a space tourism in the future?
Can you repeat again?
Let me talk about space for a minute. If people that go to space say if you've ever been on a ride or somewhere where you have zero, you know, like an airplane where you have zero gravity and your stomach goes up into your throat, in the space station, there's no gravity. Your stomach is always, according to guys that have gone there, your stomach is always upset. You're in space, all the sound in that thing, you have all the fans running and sound, there's no dampening of the sound. So you have all this machinery running. The air is bad, stale, it smells bad. The waste management system is not good. So, you know, it sounds, you know, you see the movies where they're on this luxurious space station, you know, and it's orbiting to give artificial, and you're jogging and you're, you know, all this stuff. That is not space travel. That's Hollywood space travel. It's not, from what I understand, it's not comfortable. These guys that are paying $1 million to go up in space, I don't know, they go up there and get sick and come home. But unless you're been accustomed to it, you know, like the test pilots, you know, they're pretty tough. But the average person would probably find it very uncomfortable.
John, I would just add, they're still trying to perfect the bathroom facilities. That's still a work in progress.
At one time, the space station smelled so bad that people were getting sick from the smell. So what do? You're up in space. I mean, you have very limited tools and access and chemicals, you know. So you just have to learn to live with some of the problems.
Yeah. I have watched a video, sir, about space. I'm also curious about the food they eat. It's dehydrated.
Yes.
Yeah.
The food.
Yeah. They perfected a lot of the food now so that, you know, you can get the nutritions and fluids and everything you need. So I think that part of the, although there was a time there when they almost ran out of food. We were depending on the Russians to launch the cargo up, and I think they had a fire or some failure, so they missed one cargo thing, and then they were running low on food. You know, you're up in space and you don't have anything to eat. That's not a very good situation.
So there's no fine dining up there.
There's no 7-Eleven. There's no There's no sorry store. You can run next door and get something.
Oh no. There's no mini store or anything convenience store to run to.
I don't know.
No, I saw the one there's no
I don't know. You know, if they really ran out of food, I don't know what would happen. They become cannibals. I don't know.
They can draw the short straw.
Oh,
Yeah.
no.
So that if you run out of food in space, you want to lock yourself in your chamber in case they get done.
Hey, John, I think you might have an idea for a screenplay.
Yeah, I think cannibals in space.
I believe that's a good Netflix story, no? Okay, Phoebe.
I'm sorry. I'm not done laughing. Okay. Okay. For our next question, Sir John, what can you say about NASA's Artemis program? NASA and Boeing have been working on SLS and Orion capsule for nearly a decade. Why do you think it took nearly 50 years to build a rocket as good as the capabilities of Saturn V?
Can you repeat your question again, please? Because you were talking.
Did you get that, Carrie?
I'm sorry, could you repeat the question?
Yeah, I couldn't. You were broken up. I apologize.
Okay, sir. What can you say about NASA's Artemis program? NASA and Boeing have been working on SLS and Orion capsule for nearly a decade. Why do you think it took nearly 50 years to build a rocket as good as the capabilities of the Saturn V?
Well, it took 50 years to build the rocket, which is the Saturn is just like the same.
I think the International Space Station and all that effort has taught us a lot about building complicated systems. Rule one, make it as simple as possible. You know, the simpler the system, the more reliable and the less things that can go wrong. The ISS is very complex, and the idea of having multiple contractors and different countries and all, that's a good concept, but it's not really practical. It's better to have one company do everything, do it simple, and test it all out, one contractor, and much cheaper. But, you know, NASA, like I said, really has a PR effort. And part of it was we're going to have these international partners. And that was a good concept for PR and for promotion. But in reality, it's very hard to coordinate, you know, international partners. And it makes things more complicated. And I think it introduces more risk. So in the future, I think this SpaceX, where you got one company doing the module, doing the rocket, doing almost all the heavy work is a way to go. It's cheaper and better. The real capabilities of NASA lie with the contractors, and the contractors have to be willing to take the risk and devote the resources to support NASA. Okay.
I believe one of our panelists have a question. Engineer Agatep.
Yeah, I have two questions. It's regarding the COVID-19. One is that there's a scenario that the Earth is no longer livable because of COVID-19. Is it possible to have a colony, or let's say a moon on Mars, to save the race of human being not to be eradicated because of this COVID-19? And the second question is, what is Boeing doing something on commercial flights? What will be the new normal for commercial flights? Is Boeing designing a new commercial airplane?
know,
Because of the COVID, are you going to decide?
a pandemic on Earth, I think it's well overblown. The death rate is very low. The risk of living outside the Earth are thousands of times more risky than the virus. You know, I think if we had a colony on another planet, it would be very small. It's very hard to maintain. If we could find a planet with the resources of Earth, I think we could colonize it very, very, other than getting there, I don't think we'd have a problem. And I think that's the ultimate goal, is find, the planets near us are all really not inhabitable. The moon, the Mars, there's no resources. There's no atmosphere. So I think we're sort of stuck here on Earth, really, for better or worse, and we need to concentrate on the science on Earth. The pandemic in Texas, we're seeing more and more infections. It's pretty low. I think you just have to live with that. The big thing is, I think the Chinese did everybody a disservice by hiding it, and they're still hiding it. So China seems to be the spawning place for all these diseases. So we really need to put pressure on China to straighten out and be more transparent.
John, I would just add one more comment to that.
But
yeah, if we were to colonize a planet whose atmosphere required a domed city, a domed enclosure, then I think the spread of a virus would be far, far greater risk in that kind of an environment, just because air is being recycled and it's a confined, maybe a crowded area. So it might actually be much more dangerous to live even in a domed city on the surface of a planet.
My question is, both doing air travel in the U.S. right now, I wouldn't recommend air travel. The air systems on the airplanes do nothing to reduce contamination. Basically, they recycle the air, they cool it, and they scrub a little of the nitrogen out of it. So if you're flying in an airplane, that air system is carrying whatever virus or bacteria, whatever is in the airplane, is going to be circulated throughout the airplane. They could have done something to improve it, and I think they will, but everything on the airplane is weight sensitive and cost. So, if you wanted to put another 50 pounds or 100 pounds on the airplane, you'd have to fight the engineers and everybody to justify it. But now with this pandemic, I think they will. They're going to put some kind of scrubber in there so that the air is much cleaner, better, in order to lure the passengers back onto the airplane. If you're in an airplane and you're sitting next to somebody that's infected and they're contagious, you have a high risk of being contaminated also. And you're sitting there for 6-8 hours. If you're going to the Philippines, you're on the airplane 14 hours. Somebody coughing on you for 14 hours, you're going to be sick too, That's just the reality. So right now, they haven't done anything. That the air systems are they're not really substandard. Forget the contagion. They don't clean the air well enough. And one of the reasons you get off an airplane, you're tired, I think, is because the air is bad. They can do something, but you got to have I think the airline companies will go to Boeing and say, hey, you got to do something to fix this so we can get people to fly again. That's a good point. Thank you.
Yeah, so what we're saying right now is that the claim of the airlines that they filter the the air circulating in the cabin is not that sanitized. It's not 100% sanitized. So maybe how many percentage of sanitation that the air that circulate inside the cabin, or what percentage you'll be getting the virus of people inside the cabin.
Well, the air in the airplane, I think most airplanes, they picks the air up in the front of the airplane and circulates it to the back. So if you're going to fly in the airplane, I would fly business class or first class. But right now there is no protection. Whatever virus can survive at, I think the temperature of the airplane is maybe 68 degrees, then it'll survive. It'll get spread if it's on an air droplet or a dust droplet. If it's a big enough droplet, there is a filter in there. It may be filtered out, or less. I think they're about 200 microns big. They're very small. So the air system really does nothing to suppress it. Big thing is if you're on an airplane and there's somebody sick near you, you have to insist on moving away from them. Put your mask on, move away. There is no easy solution.
So maybe when you travel, you wear a PPE.
Yes.
Yeah, if you
A protective device.
whatever you feel comfortable. I even before this, we tried to travel with a mask because you still had the flu, you have colds, you have other things, and the airplane's an ideal environment for spreading. Not only inside the airplane, but then the sick person gets off and he's in another country who has 0 cases. Well, he's case 1 and he's out spreading it around. That's what happened. We found that the Chinese took off and spread it to Europe and Australia and all over the world. Almost all of it was
Anyway, another just
almost all
last
contagion. There's a program that tracks the cell phones of the Chinese in Wuhan, China, where they went. And you can see them all departing, going all over the world, and primarily to Europe. And sure enough, in Europe, within 2 weeks or 3 weeks, they started having cases. So there's really no mystery of why it spread around the world. The airlines spread it. The Chinese air travelers spread it, initially anyway.
there is a rumor that
There's no mystery.
it's not a virus, but it's a human-made virus coming from Wuhan, one of the biomedical laboratories in Wuhan that accidentally released the virus.
Yeah,
What is
I believe that too. I think they were playing around with it and they're very sloppy and they're under budget, and they, from the documentation, their lab was very unsecure. So that's probably what happened.
Okay, thank you very much.
You're talking about the damage in the US, the damage is terrific. You're talking about trillions of dollars in loss. We've got 110,000 deaths, and there'll probably be another 100,000 by this fall. So you're talking about 250,000 people in the US dead. Of course, Europe has got a lot of deaths. I don't know how bad the Philippines is, but the toll is terrific.
And I think we have not seen yet the end of the road, the light at the end of the tunnel. We have not seen yet the light at the end of the tunnel.
No, I don't think there's going to be a vaccine anytime soon. I think just people get immune to it. You build up some immune, just like the influenza. You build up some immunity, and maybe you won't get it next time, or if you get it, it won't be as severe. The big thing is to build up your immune system. Take zinc, vitamin C. If you're an elder person, you need to take all the vitamins. I think zinc is very important.
Okay. That's good.
That's all you can do is build up your immune system.
Okay, thank you.
Thank you, sir. Good question.
Thank you, Sir Romy. That reminds me of the movie World War Z.
Yeah.
Oh,
It's very
Yeah.
scary.
I saw that movie. That was interesting.
and the contagion.